Hello friends. Now, in this fifth lecture of your topic structure of atom, we are going to discuss about a spectrum, which is electromagnetic spectrum. And how does electromagnetic spectrum looks like? It looks something like this. So, over here, the very first thing what we need to observe, let's see. Okay, the very first thing what we need to observe and what we need to remember is the gamma rays that you have in the spectrum over here. So, the gamma rays, these rays are highly energetic rays, whereas the radio waves are the least energetic waves. So, can I say a very first point? Listen, can I say that as you move from your right hand side towards your left hand side, okay, moving from right hand side towards the left hand side, the energy of the waves goes on increasing or decreasing? Then the energy of the waves goes on decreasing, that is moving from gamma radiations towards the radio waves. What would happen is the energy of the waves would go on decreasing. So over here, moving from right to left, the energy decreases. Okay, let's see further. Hey, also observe the diagram. Okay, now moving from gamma radiations towards your radio waves, gamma radiation has a wavelength of 10 raised to minus 12, whereas radio waves has a wavelength of 10 raised to 1. That means, can I say, moving from right hand side, that is from gamma radiations towards your radio waves, what is happening? Once again, moving from right hand side towards the left hand side, what is happening? Then your wavelength, that is lambda, goes on increasing. Okay, that's great. Okay, one more thing, let's listen. What we have observed, and we have already learned a equation that is nothing but Maxwell's electromagnetic equation. Okay, so in that equation, if you remember, we talked about C is equal to lambda into mu. Okay, that's fine. Okay, over here, if you just check, C is a constant. Therefore, can I say lambda is equal to C upon mu, which is nothing but, or which can be represented as lambda is directly proportional to 1 upon mu, or I could say lambda and frequency are inversely proportional. So over here, just check the diagram. From right to left, your lambda is increasing. So what would happen to the frequency? From right to left, your frequency would go on decreasing. Okay, the frequency decreases. Okay, let's move further. Also, if you notice, somewhere in the center, that is around a path of 10 raised to minus 8 nanometers to 10 raised to minus 6 nanometers, you have a visible spectrum. Now, let's check a very simple example. Okay, imagine you have a metal block, or imagine you have an iron block, and if you just keep on heating it, what would happen? The very first thing what you would see is that your iron block gets converted into red color, or you would get red hot iron. Okay, if you heat it further, this red color would change slightly into orange color. If you keep on heating it further, orange would get converted into yellow. Now just check your diagram. The very first color that you observe around 700, okay, is red. So you have a red color over here, but then after red, the color slightly changes towards orange, then it changes towards yellow, then you would get green, then you would get violet, then you would get green, then you would get blue, and then finally indigo and violet would keep on following. But then what is the thing that you need to understand over here? Moving from red towards violet, once again I repeat, moving from red towards violet, what is happening to your energy? Is your energy going on increasing? Then yes, we have said something like this, that from right to left, the energy decreases. That means from left to right, the energy has to increase. Okay, let's leave iron block. Let's take another simple example of sunrise. Whenever you observe the sunrise, remember the first color that you observe is always red. Then as the sun rises further, as the temperature of the day goes on increasing, what happens? Red color gets converted to orange. Then from orange you would observe yellow. But finally at 12 o'clock or 1 o'clock in the afternoon, you would see your sun, which is white hot in color. You won't see any color over there. You would see it's white. Okay. If you haven't observed, I would suggest go and observe. At 12 o'clock in the afternoon, your sun would be white hot. And why is it white hot? Let's understand this. It means that starting from the red color, as the red color gets converted to orange, then to yellow, then to green, then to indigo, then to violet, and all the spectrum. Then it moves towards the UV spectrum. And our eyes are not adapted to see UV light. Am I right? And therefore what you can see is, you can see all the 7 colors together. Earlier क्या हो रहा था? तुम्हें सिर्फ red color दिख रहा था. Okay, in that also you were seeing only red color because it was having highest intensity at that point of time. Okay, but then there were all the other radiations also present in your atmosphere. We would prove that slightly later using a black body radiation experiment. Let's not take into that. So earlier you were observing red color. Next you were observing orange, then yellow, then finally you observed sun, which is white hot. But whenever you observe the sun as white hot, I would say white hot object, that means what I can say is your sun is giving out all the 7 colors together. And if he is giving out all the 7 colors together, that means I can say your sun has moved from the visible spectrum towards the ultraviolet section. Okay, if you heat sun furthermore, from ultraviolet it would go into gamma radiation, but that doesn't happen, don't worry. Now over here, what examples did we give? We gave an example of iron block, we gave an example of sun. Okay, take an example of iron block. Imagine you are heating an iron block. What's the first color that you would observe? You would observe red, then you will observe orangish, then you will observe yellowish. Okay, this means what? This means that whenever heat is given to any particular object, that object changes the color. And if the color changes, just check over here, if the color changes, that means, can I say the color is changing? That means your wavelength is also changing. And if your wavelength is changing, your frequency also changes. But then, do you remember we just did something called as Maxwell's electromagnetic theory? And in that theory, if you remember, let me just put a screenshot for you. If you remember, we have done something saying that is the energy is lost or the energy is gained in a continuous manner. And this continuous manner means that there is no change in frequency or no change in wavelength. Right now, what are we observing? We are observing that whenever we are heating an iron block, whenever we are giving energy to a particular object, that object changes its color. And if color changes, that means your wavelength has to change. That means your frequency has to change. That means your energy has to change. And if this is happening, we could very firmly say that your Maxwell's theory is having some defect. And what is that defect? We would prove it in the next coming experiments. That is black body radiation, and the second one is photoelectric effect. Till then, thank you students and happy learning.